Now we'll draw the Lewis structure for CO3 2-. Again, carbon only wants 8 electrons, and our oxygen wants 8, and there's 3 of them. So that gives us 24 plus 8 for a total of 32 for our octet number. Now we have this negative charge in here that we're going to have to take into consideration when we count up our valence electrons. So carbon again comes with 4, oxygen again comes with 6, and there's 3 of those for 18. And then we've got this 2-, so that means that we're going to add 2 electrons to the tally. So we've got 4 plus 18 plus 2 for a total of 24 for our valence electrons. 32 minus 24 gives us 8 for our bonding electrons. 8 divided by 2 gives us 4 bonds. Now we'll take our valence electrons minus our bonding electrons, which gives us 16 for our non-bonding electrons. Notice that we've got 3 atoms to be attached, and we've got 4 bonds, so we will be in a regular octet, so when we get down further we will not have an expanded octet. So now we've got our 16 non-bonding electrons, each of them going in a pair to make 8 lone pairs. Carbon is less electronegative than oxygen, so carbon will be our central atom. And again, we've got 3 atoms to attach and 4 bonds, so we do not have an expanded octet. So our carbon is going to go in the center. We'll attach each of our oxygens. Notice right now I've only used up 3 of my 4 bonds, so I need to put 1 more bond in there. All of these oxygens are equivalent to each other, and when we get to the resonance video we'll talk about this further, but at this point in time we can add our second double bond, or our second bond to any one of these oxygens. So now we've used 4 bonds, and we've got our 8 lone pairs to divvy up. Carbon is seeing 2, 4, 6, 8, so its octet is satisfied. So we will want to put our lone pairs around the oxygens. This oxygen right here, so we've got 1, 2, 3, 4. So it's seeing 2, 4, 6, 8. Its octet is satisfied. This oxygen, 2, 4, 6. And then our bond is the 8th one, so its octet is satisfied. Our last oxygen, 2, 4, 6, and the bond is 8, so its octet is satisfied. So we'll count up our electrons: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That matches the number of valence electrons that we started off with. Now there is one final step with this structure here. Because we started off with the -2 charge, we put a bracket around it and put the -2 charge in on the Lewis structure. And now we've got the final Lewis structure with PCl5. Phosphorus is going to want 8. Chlorine is also going to want 8 on each of its 5 that are in there. So that gives us a total of 40 from the chlorine plus the 8 from P. So we've got 48 total for our octet number. Phosphorus has 5 valence electrons. Chlorine has 7, and there's 5 of those, so that gives us 35 from chlorine for a total of 40 valence electrons to work with. If we take our octet number and subtract our valence electrons, that gives us 8 for bonding electrons, and 8 divided by 2 would give us 4 bonds. So this is now where we are seeing we've got 4 bonds and 5 atoms to attach. So we don't have, so there's not enough bonds for the number of atoms that we have to attach. So we are in an expanded octet situation. So instead of having 4 bonds, we have to have at least as many bonds as we have atoms to attach. So we are going to have 5 bonds. So now with our 40 valence electrons, we'll subtract our number of bonding electrons. So if we have 5 bonds, that's going to be 10 electrons. So we will have 30 for our non-bonding electrons. And that 30 will be divided up into 15 lone pairs. Our phosphorus is going to be our least electronegative element, so it's going to be the central atom. And as I said before, yes, we are in an expanded octet. This works out because our phosphorus is in the 3rd row. So as long as our element is in the 3rd row or below, then our expanded octet is a possibility. So now we can draw our Lewis structure. We've got phosphorus in the center, and we have to attach our 5 chlorines. Now you'll notice we are an expanded octet, so this phosphorus is seeing 2, 4, 6, 8, 10 electrons. That's fine. Again, it's in the 3rd row, so it can handle more electrons. Our chlorines are each only seeing 2 electrons at this point in time, so we are going to divvy up our 15 lone pairs, 3 to each of these 5 chlorines. So we'll do a quick count. 2, 4, 6, 8. So each chlorine is seeing 8 electrons. So each chlorine has its octet satisfied, and we'll count up for our valence. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. We started with 40 valence electrons, and we've got 40 in our Lewis structure.